session. So maybe it will be the last part of our online learning session that we kind of have. Let's have an open discussion on majority of the topics that we kind of have discussing. So we have Hasan also with us. So Hasan, if you don't mind, yeah, hi Hasan.
Hey Hasan.
Hi. Hi. So we have Hasan and we have Jonghyun too. So I feel just for this session, we'll probably go one more round of, let's say, self-introduction. And then, I mean, for the new participants that have joined so far. So we'll just go across the board. I mean, at least three of us, and then I mean, we'll get started with the discussion.
Sure.
Okay, I guess Jonghyun could go first.
What should I say?
So
okay, I'll go first to lead by
Yeah,
example.
please.
So
Yeah.
I'm Hasan, PhD student at King Abdullah University of Science and Technology, and currently I'm an intern at Oxford University with Philip Tour. And it's 5 a.m. over here. Yes, I look very sleepy. I work on online continual learning and offline continual learning, both of them, on a slightly different paradigm than the one Jonghyun is working on, where the streams are actually they actually come from data sets which are created on top of, for example, let's say Flickr stream or Google Landmark stream. So actual data sets uploaded by individuals with shifts across distribution and labels. And I focus mostly on computational budgeting and correction of metrics currently. And yes, that's it. So I could talk about that later.
All right. So for me, I was working mostly on the online continual learning setup because the online is the actual scenario that the continual learner is going to be facing. So that's why. But I also be interested in this offline continual learning because, online continual learning models are basically underfitted model because we don't have much of computational budget to train sufficiently on the data stream. So and also, I think the computational budget and the story budgets are going to be the strict restriction on the method comparison. But the current methods are compared in different, computational budgets or the different storage budgets. So the comparisons are not really fair. So that is something I am really interested in for the future research, as the Hasan is going to be interested in as well. And also, I'd like to extend all of this continual learning based methods on multiple different field. For example, this embodied AI or foundational models or any different thing, because this is basic learning paradigm, not only for specific application, but also can be used for universally on many different machine learning methods. So yeah, I'm interested into adopting this technology to many different applications of machine learning. So that is it.
great. I mean, thank you. I mean, thank you both of you for giving a brief intro into it. So, as we are very much focused on this online setting, very specifically in this topic, right? I mean, in this session, I mean, I just wanted to kind of start off to get your thoughts on a very practical setting where, I mean, the main focus of this online is that you will get only a single pass through your data stream. So that's what we call as online, right? And then we have this flow of data coming in, and then you have a single model, and then you want to learn everything continually and incrementally. In most setups, when in a very practical setup, right, there would be some set of classes that indeed comes by, and they would have its peak, and then and slowly it might die off, and it might indeed, I mean, like for a pure online learner, there might be a set of classes that would be very important at a certain point of time, and then some time later they might not be required at all. And for us, we humans, I mean, we have this very beautiful thing of forgetting. So, I mean, as continual learning folks, we always don't like forgetting. Like, I mean, catastrophic forgetting is our bread and butter, and we try to fix that. But do you guys feel that, there is an actual need of proper forgetting at times where, I mean, like, as in when we are learning something new, there might be some concepts that should have been erased from our memory, or else it can ideally be adapted to something new. So, I mean, any thoughts on, let's say, continual learning with forgetting?
Yes. So I do believe that we humans do forget things, but yet we do learn general representations of things. And in a like in a real scenario where you have a natural data stream, you almost have no guarantees on whether concepts will be repeated or not. If you have the privilege of knowing so, then yes, probably forgetting or doing some erasing of information, dropping certain samples or classes from memory would be useful. However, in a general setting where you have, let's say, Twitter, and you're talking about elections, every few years you will talk again about elections, and concepts will be re-emerging again. And in our work, we showed, in an ICCV submission this year, accepted paper in ICCV, we showed that uh, the best performing model in online continual setup. For us, on online continual setup, we study two definitions of streams. We have something called fast stream, which is you do a single pass over the data, or at least you are given a budget, which is equivalent to seeing, with the simplest method, you can see all the stream once. And we have slow stream, where you can do multiple gradient descent steps, and we scale this according to different methods. What we find is the optimal thing you can do in online continual learning is offline continual learning methods. Once you do proper budgeting, unlimited memory, and you actually take into account the corrections of online continual learning metrics. So currently, the way people usually measure accuracies in online continual learning, they simply say, oh, how good is my learner in predicting the next batch? And they just accumulate this over the stream. However, we found that this might be biased based on the correlations in the stream. If a user uploads images of their travel to Paris, for example, all of this batch would be labeled as Paris, for example, if you're doing geolocation. And therefore, if we look at the batches, let's say I upload 2,000 images, and this is what actually happens in current data sets, you would find correlations all along the stream. So in a real life scenario, what we found to be most useful, if we take the most realistic setting for us, which is compute budgeted, unlimited memory, we find that the best thing you can do is uniform sampling over the stream, because we don't have any priors on what you should forget or what you should remember for the future. So that's from my side.
Interesting.
Meaning that you shouldn't forget anything, or sorry, I don't get.
If you have no access or knowledge about what things will disappear, and your data set simply presents you with new samples, we found that the best thing you can do is learn generalizable features by simply uniform sampling on previous samples that you have in your buffer, in your unlimited buffer. If you have a prior on, or if you, let's say you have a measure on, if this class doesn't show up in the next 2 years, then I can simply drop it or do some regularization to drop how important it is for training. I could simply regularize the loss for all samples.
Yeah, that makes sense. Yeah, to me, if you have I mean, this is kind of similar answer. I mean, based on different assumption. As Hassan says, we don't have a proper, if we don't have a proper method to judge whether the sample is going to be important or not in the future, then we should do what Hassan just said. But if we have some sort of prediction system of future necessity of some samples, then I mean maybe we can use reinforcement learning, or we can use some predictions for the future. If you have some sort of measure, then we can come up with the we have basically the metric to measure whether we can store this information, or we have to keep this information, or we have to discard this information. So if you have access to that information, then we can use that information to balance between forget the data, balance between the data to be forgotten or the data to be kept in the memory. And I also agree that for better intelligence or the better efficiency in the learning new knowledge, we have to forget something. Otherwise, given the fixed size capacity of neural network, we probably have to struggle to which information to be kept, which information to be new learned. So to accommodate in learning new knowledge, we have to forget, maybe, given a very small capacity of a neural network to host new information.
True. I feel that's a very, very valid point. And I mean, two cents from my side. I feel uh, at the end of the day, we might actually have to learn concepts that are invariant to these, let's say, set of classes, and then there might have to be some kind of an adaptation that is class specific that might really go on. So, I mean, if we can devise a system like that where it's more concept, and at the end of the day, you assemble these concepts into classes and then do a classification. If that's the classification of the end task, I think that'll be a very, very natural way to kind of go about doing it. In that case, it will be very easy for us to kind of maybe adapt an old class into a new class which is related, but is quite different too. Right. Yeah.
Yep, makes sense. Well, we have a question from James. Oh no, James is not
Not me, from Marty. He's saying, and by the way, if you've changed your audio setup and want to come join us, feel free to. But he said, in most real-world online applications, don't you think that in general the data tends to gradually shift, and therefore we can take advantage of that tendency?
This is a great question. Yeah. I mean, analogy of, chain of thought in language model. So if you have a proper steps towards the reasoning, then you can basically you basically don't need to retrain the model and things like that. So if we have, this is related to the curriculum learning, I guess, in the time series. So if you have nice curriculum in the time series, then we can probably take advantage of that tendency or the shift amount or the shift directions in the data change so that we can leverage that information to have less forgettable continual learners or more efficiently learned continual learner on the new knowledge.
Yeah, and I also think like regarding the shift, it could be defined either as distribution shift or as label shift. And if it's repeated labels, then this might be more harmful to the network to learn. On top of that, a very simple baseline, if you know that, like in existing data sets, a very simple baseline is fixing your backbone and just doing linear probing. And this is because those data sets actually do have a lot of label correlations in the stream. And you can get state-of-the-art results simply by doing such a recipe, where you just adopt a backbone, fix it, and learn the label correlations using a linear layer. If you actually expect such a stream in real life, or you know that your task has such correlations, and you actually don't care about remembering old concepts, you just care about like your online accuracy for the stream, giving people the best result you can, then yes, you can benefit from those label correlations by adopting such a baseline.
So those correlations are given in the hierarchies of labels that I just mentioned.
Yeah. I mean, they are also there in existing data sets, and those correlations go up to 16,000, for example, in clock, which is like 16,000 samples still have some kind of a correlation that gives you a non-trivial accuracy. So yes, I mean, it really depends on how much the downstream is important for you in terms of retaining knowledge compared to actual good predictions in your online setting. So if you know that someone is predicting samples of, like, they uploaded a bunch of samples, and you know that they took many images in Paris, then it makes sense that their next few samples might also be in Paris. And this is how current data sets are.
Yeah, I think, I mean, there was a very grounded discussion. And I feel connected to all these, I feel as the most important criteria for any research to kind of thrive would be proper evaluation metrics, right? So, I mean, in your talk, John, you did, I mean, spot on a couple of, ways that you were kind of having, there's an area over the entire area. I mean, the curve to actually fit how good, the evaluation metrics is, right? So, I mean, what do you feel? Where are we? I mean, how important is it for we as a research community to standardize metrics for specific, let's say, online continual learning? Should that be different from the standard continual learning? So, any thoughts on that?
Oh, this online continual learning, this is basically just continual learner. So we probably don't need to have a new metric, but as I mentioned, this AAUC kind of measure. I mean, the teens group has different name for the very similar thing. They have like AAAA or something. So these measure that computing the accuracy of all time maybe is necessary for the online continual learner, because we have to ensure that this online continual learner performs consistently well over the sequence of time. So yeah, that may be one metric that we may necessary for the online, but for now, I don't see any new thing necessary immediately for
I
the
actually
online.
think like some metrics are needed for, so for example, in ICV, we proposed a metric which basically combats this label correlations. So let's say I don't really care about just doing good performance in terms of label correlations, and I really want to see if the network is learning properly. So what we found is that if you simply do this next patch accuracy, which is your regular online accuracy, then you're simply measuring how good the method overfits to the label stream. And this gives a false ordering of which methods perform best. So we benchmarked a bunch of methods and we found that a particular ordering. And then we proposed a metric which says, oh, don't predict your accuracy directly on the next batch. Predict the accuracy K batches in the future. And this K is just enough to break the correlations, the label correlations. And then once you do that, we find that offline continual learning methods and simple experience replay can actually outperform all existing methods on this metric. So I think metrics do matter depending on your downstream, so your actual application in real life. So whereas near future accuracy in the presence of label correlations simply tells you how good you overfit to the label stream, or how well you understand the label stream. And in online accuracy, there's like a one baseline, which is a blind classifier baseline, which doesn't look at images and only looks at labels that were presented in the past, and it can already beat SOTA. And this is quite alarming. So if you simply report online accuracy and you can beat SOTA by looking at label correlations only, then yes, like the metric does say something about you don't really need a network in that case. Then you can only look at labels. Whereas near future accuracy, the blind classifier fails miserably because this is how it is actually built. I think you're muted, Joseph.
Yeah, and I feel, I mean, if we can shape these accuracies to better match its real world application. I mean, if we can quantify how good or bad, let's say, I mean, like if we can define an accurate, I mean, like a metrics that kind of sees how much practically viable each of these online content learning approaches are, I think that would be great. I mean, for instance, if we want to, let's say, have a classifier that is to be deployed on top of, let's say, a robot per se. And I mean, in such a setup, I mean, your false positives would be very much, I mean, harder to kind of have rather than a true negative, right? So such mission critical, I mean, applications for this online continual learning setup. So I think, I mean, getting more matrices that kind of measure how much the specific application would go downstream. I think it might maybe help us to kind of, give a bit more insight into how this actually gets deployed. Yeah, and I mean,
You go first.
yeah, sorry, go ahead.
Yeah, Hasan, you go first.
Oh, I just agree. I didn't say anything.
Right. I mean, maybe in a couple of other tidbits. Maybe I think if we really think about it, when we as humans, I mean, just go about learning online, right? In many cases, it would be possible for us to maybe identify and come up with some weak labels, so to say, or necessarily if we even if we might not be able to identify something as completely a new instance and give it a specific semantic label, we would be able to categorize it into something that we already know almost quite well. For instance, like if I mean, so when I traveled to Paris, I think I had I mean for ICCV, I think the main thing that I enjoyed was the food. But but whenever go to a restaurant, all the language would be in French, and then it will be very hard to kind of choose which menu from that from the list that we kind of have, right? Which food from the menu. So in most cases, the way that I could figure it out was, one, if there are some imageries, then I can probably relate that to one of the existing food items that I might have had elsewhere. So meaning it's I would say that that's kind of an online setting where you are in a different domain. I'm kind of put in a different, in a space where everything is from a different distribution. The food is from a different distribution. The roads are in a different distribution. The buildings, as John, as you are kind of mentioning, everything is pretty old and antique. So that's also a different distribution. And in most cases, we would be able to adapt to those newer distributions. Without kind of much forgetting what do we kind of have. So what would be the core, building block that we might have to bake into our let's say artificial neural networks that we are kind of building, so that it will be very easy for us to kind of transfer the new items into related existing items that we kind of already know about, and then build that semantic structure and then get going from there. So, would that be an interesting direction to pursue in online continual learning?
I think for companies, if they want to do online continual learning in such a setting, they would simply deploy a foundation model and like predict using it as a foundation model. If you get one of those foundation models and you linear probe it on the online continual learning data sets, it can already like almost ace those data sets. And this is quite interesting, but I guess as a community, we shy away from those foundation models because there might be an overlap between your training set and you might have seen those labels, or you might have seen some samples. But when it comes to real life, like no one restricts you on what you do on your pre-trained backbone. You can simply take Dino V2G, whatever the biggest model you want, and deploy it. And you would get a very high accuracy. And another thing is that we really shy away from using the internet as a data source. Like the internet is there. If you want some samples from the internet, why not? Currently, the community is a little bit shy about using outsourcing data, or so like, whereas in a real life applicability, you can do whatever you want. So I do think like in real life, what you do is you do self-supervised training on a very big corpus of data. You would get this very strong feature extractor, and then you either train an adapter, linear probe it, do KNN, whatever you want in a real life setting. I think this would be most of the baselines that we have with smaller backbones, less data, and so on.
Yeah,
For
that's
yeah, sorry.
Go
So
ahead,
for
go ahead.
your mentioned problem is really interesting, and I also have been interested in that problem for more than 10 years. So
Wow.
my first paper is using this class relationship between relevant class conjuncted by the visual attributes, so that we can get the unlabeled sample for the relevant class, looking at the attribute kind of description. That was my CVPR 2013 paper. So if we don't have that kind of, if we are using this one hot vector encoding, then we pretty much ignore all of the relationship of the classes. Because, if you say, yeah, this is the orange, not the grapefruit, then come on, they are really having not just grapefruits only or the orange only. They are like some portion of images are looking like grapefruits and some portion of it looking like orange, right? So we need to really have really smooth distribution over the label space, so that we can naturally encode the relationship between the classes, so that we have less forgetting in the parameter updates by using the artificial gradients of these artificial labels. And anyway, we are using stochastic gradient. So maybe this one-hot vector encoding will be fine. And if you're using this sophisticated soft label, still we are suffering from forgetting because of the stochastic gradients. But at least we may converge to the better local minima, maybe. And maybe we can have expedite the convergence speed as well. And those kind of benefit is what I can imagine for encoding this kind of situation. But for that, we need to have this a smooth distribution over the label spaces.
Sure. Maybe a related follow-up question to that would be, if that is the case, where whenever we learn, we kind of learn from a data stream, and then we are in an online setting, and if we know that a new instance that came in is new, and at the same time is semantically related to a couple of existing data points that we kind of know, can we categorize that as a new class? Not necessarily not giving it a semantic label, but instead we can know that there's a new, like suppose it meets some kind of a threshold to say that it's different from whatever you kind of know, but it's related to these all base classes. Hence, I'm going to categorize this into a new class. And then we should just go on continually learning in the data stream. So the data stream again can potentially contain old samples, completely new samples, and whatnot. But so if we can do something like this, then what we are indeed hinting at is some kind of a universal learning system where people just you deploy a model, and the model is good enough to identify whether something is new. If it is new, it may not potentially give it a semantic label, but still it can identify them as a new class and then keep going from there. So, what are your thoughts along those lines? Are we there, or is it some north star that we should actually worth chasing?
I think this would be very interesting. Like lately, I was playing around with Dino V2 particularly just for dataset cleaning. So I was working on some project where we collect samples from the internet, and the internet is full of noise. And basically, we just forward pass through Dino. We take the features and we do some KNN, regular cleaning. Basically, if you have a cluster that falls away from all other clusters, then this seems to be an anomaly, or based on samples, if they don't belong to any cluster based on a particular threshold or cosine similarity, you just drop it. And what we found is we scraped a bunch of samples that are a completely different classes, which is we had cars, Stanford cars, and particularly we had a blob of wheels, which is like clustered as a blob of wheels. They are part of the car, but yes, you can basically identify this as a new class. So I think with those very massive foundation models, it seems we can kind of find new concepts. I'm not sure how well it would transfer though to medical domain or such streams. Like let's say you have a stream of medical data, then I don't think we have any self-supervised model on such data. But for the general purpose data of like, cars, cats, animals, whatever, I think we do have good feature extractors that could do that, like could identify new classes, and most probably this is because of the corpus of data that they've seen. Like they've seen some similar concepts.
Part of that challenge that Joseph just mentioned was addressed in my hierarchical label expansion paper. But for the supervised training of online continual learning or the continual learning in general, I think as Jan mentioned by his famous cake analogy, the supervised data, the supervised signal is pretty weak signal to encode this data points. So we maybe can find a solution by using the unsupervised learning method or the self-supervised learning method to capture the essence of this information, whether it is going to be belong to some previous class or the current class and things like that. And they really have to find a way to figure out which class membership should be used for the class membership of this sample. Whether it is going to be the previous one or the new one, or whether we have to introduce a new class. So this problem also arises that we don't have a notion of don't know class,
Yeah.
So if you do the classification, we are try to max out the really similar classes to the among the given label space. But this is not what we are doing. If you as a human, if you find that this is not really similar to any of the classes that you know, then human will say, yeah, this is what I don't know. But as a machine learning, in any machine learning model, we assume that any of the sample is going to be some of the sample of some of the classes, which is wrong assumption. So with that, if you have a notion of don't know class, then we may probably open the door to those kinds of open word or open vocabulary classification things. Yeah, so
Absolutely.
it's a combine the challenge of the open vocabulary kind of classification thing and also the problem of the supervised learning.
Yeah, that's a very interesting take. I think once we kind of have some idea to how do we kind of understand something whatever is known and unknown. I think that's a key challenge that we might have to overcome to really understand and get this going forward. Yeah, very nice.
Yeah, I think
Yeah,
one more
The-
thing on the evaluation. I think we're still stuck to very old data sets during our evaluation. Like the other day, I was working on some samples and I was checking the quality of fidelity of certain samples from data sets, like, for example, PACS or Stanford cars or something. And the images are in terrible quality. And then we judge our models, which might be outperforming those by big margins simply by the quality of very old data. So
got it.
particularly when you want to use the web for getting samples, you can get way better quality samples compared to what you have on those old data sets.
It is.
Like, yeah. And
Right. Yeah,
yeah.
I mean, to be honest, that was one of the discussion points that we actually wanted to talk next. And I think it's a good segue into that. I feel, I mean, how do we go about evaluations? Not just about the metrics. I think it's more about the benchmarks too,
Yep.
right? And I mean, and the benchmarks that we currently use are all, let's say, CIFAR, I mean, ImageNet, Split ImageNet, and I mean, and so on and so forth in let's say vision space, at least in vision-based continual learning approaches, right? I mean, so what are your thoughts on coming up with newer benchmarks? So, I mean, maybe a related discussion point over there would be, let's say, the rise of generative technologies, which can actually generate a lot of images with multiple concepts and so on and so forth. That is very much relevant. I mean, like, and I mean, the expressivity of the expressive power of such generative models are now close to real. So, do you see that as an opportunity for us to revisit the benchmarks that we kind of have in online continual learning setting?
Yeah, so personally, I've been working on a line of work where we are trying to revisit this setting. We particularly do not use CIFAR, Split CIFAR, or Tiny ImageNet, or any of those datasets. We scale up to CGLM, 500,000 samples. We proposed a dataset ImageNet 2K, that's 2 million samples, and Clock, which is 39 million samples. And for us, a realistic setting is a setting where you have computational budgeting. Everyone is given the same number of flops effectively. You can do that. You are as like, take this budget, do whatever you want with it, and you compare with other methods. And we remove the memory restrictions. We find that, yeah, okay, storing three terabyte of data is like, how much is that? It's like $200 or something. And even if we think about the scale of YouTube or other companies, they are already storing the data everywhere. Like, the data is stored somewhere. So the issue is not storage, it's mostly compute. So we found certain papers that they assume that you cannot store CIFAR, which is like maybe $1 to store, and they train on for 700 or 800 epochs, which is more expensive in terms of compute by magnitude. So then there's I completely agree that data sets have to be changed. This very small scale data sets, I think they have already saturated at some point. And it's very unrealistic in terms of scale. Like, they are very small. And regarding your question on generative AI, you are given a particular number of flops. Do whatever you want. Generation is very expensive. So if you decide to go the route of generating samples, then yeah, sure, you can do that. But it's just too expensive if you can store everything.
Sure. I think the generative angle is more on, let's say, coming up with a benchmark and not necessarily as a part of the method.
I see. Yeah, I agree. But I mean, like, if it's part of the method, then yes, you're better off go scrape the web.
Yeah.
Samples. It's very cheap to get data from the, takes like a minute or something.
My take on that, if this generative model is much larger than the model that we are considering to evaluate on by using the online continual learner, then generating data by the generative model for evaluating this continual learning methods may be useful. But otherwise, if the continual learner also gets larger and the size are comparable, then I'm kind of questioning whether this generative model is actually generating some meaningful data for such a large model, because such large model just memorize all the samples and we don't need to worry about this forgetting and everything.
Sure. So what can potentially be a strong benchmark of for let's say 2023 and beyond for online continual learning?
Enforcing large-scale data sets under computational budgeting, no memory constraints, and making sure that your test set is quite reflective of actually like an actual clean test set. So like one thing that we noticed is in Clear 10 dataset, the class bus has images of interiors of buses and not exteriors of buses. So when we did web scraping, we failed miserably on this class. Like we do 10% accuracy. And this is because of this like, what is a bus then? I think we need more representative class labels. Multi-label classification would be nice also eventually to be incorporated into this setup, where we have a setup where you can actually either get captions as your descriptions of images. And another thing that would also be interesting is name-only classification. Like what if we move to name-only classification? We don't have to provide training data to the user. What can the user do if they just want to curate their own data set or get an uncurated data set? This is a very interesting paradigm that I think people should explore. But yeah, baselines, massive data sets, unlimited memory, but limited budget. And then currently under this setting, the best performing method is ER by far. Like,
Yeah, I don't know which benchmark should be the benchmark for the future, but as Hassan says, we may consider the setting that we have to shift gradually to the setting that we are not using the episodic memory at all, because this is just temporary solution. And so any large data set that we can evaluate the continual learners for many realistic scenarios, then it should be fine. Yeah, I don't have a good idea which benchmark should be there or not.
Sure. I mean, along with the benchmark, I feel the other part is about the method. And I think we did briefly skim over that point that, with the rise of foundational models and then, devices or rather technologies like ChatGPT and so on and so forth, right? So the moment that we kind of use a foundational model for any content learning approach, I think the usual comment that we get from the community, or rather the stereotype reviewer too, would be that you would be having data leakage from your foundational model to your new class. So so what should we do as a community? Should we still embrace foundation models and then start building on that? And then, so what are your take on, let's say, continual learning, or rather online continual learning in the age of foundational models?
I think there was a very interesting paper recently by NVIDIA, which was heterogeneous continual learning. And I think this is a very interesting paradigm for people to look at this point. Foundation models should be embraced. I don't think they should be like rejected, because this is what you have in that. Like this is where we are at right now. Of course, from a research point of view, it might be interesting to go and visit those toy settings and show some particular retaining of knowledge. But it seems that, yeah, foundation models could ace those data sets very easily. Whereas in this heterogeneous continual learning, what they say is that models are growing, data sets are growing. How can we distill information from one architecture, one foundation model that we have already trained today for, let's say, GPT was trained for $60 million or something. You get a new GPT. You don't want to pay the same exact money all over again. What can you do to transfer across architectures, like your knowledge across architectures, and while continually learning on new architectures and new data sets, new data sets and architectures? I think this direction is very interesting for continual learning.
Yeah, I have a similar take on this problem to Hassan. Yeah, I think we have to embrace the emergence of foundation model, because I mean the large model should have lots of new capability and lots of new opportunity to explore, which we don't know yet. And there are a lot of opportunity that we may really don't worry about the catastrophic forgetting with the large models, or we don't really worry about this bias problems on this large models. So things are going to be really different from what we are having with the small scale models and small scale data sets. So we have to use this foundation model more actively. But the problem is the computational cost. Yeah. So
I'll make
if
one
we have,
comment on, oh, sorry, I
go
can
ahead.
finish. I was just gonna make
No.
one small comment on the foundation models. I guess the first comment is something that we've observed is, the foundation models seem to be good at everything, but great at nothing, or maybe great at everything and experts at nothing, in the sense that you could even take some of these off the shelf with some of these like large data sets we do, and you still start training, and you're going to see the losses go down. Obviously, they will lose their generalization ability, but if you wanted to take an off the shelf model for your specific application, they're going to be great and fantastic and give you a lot more options in terms of weight space methods, but it's not going to be a case always where not training is going to help. So having a method where you can actually go update the weight space, you are going to get a better performing model for many problems. But as you were saying earlier, Hasan, often with the continual learning methods we have, you would find that many of those methods would well underperform just linear probing on that feature space. And then a second point I was going to make is something, very interesting potential direction with foundation models also is customization. One thing that don't know anything about is you or your interests, or like very fine-grained concepts perhaps. So I think that could be a very interesting thing in terms of how do you take a foundation model, even for maybe an industry-made model, make your version of it, learn things like your preferences, your pets, that kind of thing, and making sure it can adapt the model over time, and particularly in problem settings where you'll need to actually go back and adapt some layers, not trivial problems that can again be solved with just linear probing, and so on. Yeah, I just wanted to share that perspective. Hopefully my mind makes sense right now. It's 12:45 a.m.
It makes sense, I guess.
It does.
Yeah. And Maury has lots of questions in the QA and web chat. So Joseph, can you reiterate it?
Yes. So I think a few questions from Mark.
One of his question was marked as answered by James, but not sure whether we actually answered that question or not. The question is,
Oh yeah, it seemed to be more comment based, but we can actually go right back into it.
sure.
I think scrolling to the bottom.
Got it. Yeah.
Let's see. I mean, I'll just read it out loud. It was just talking about, I think there were some things about,
Okay, so okay, sure. So let's
Marty,
probably
is
take
the
this from
question
the
about this is your perturbative test for sampling? How about test for overall robustness of the classifier itself? In other words, wouldn't we want to select from a set of alternative possible classifier over a set of alternatively trained classifier, so using some randomization and training? Output decision conflict. So actually, the question is pretty long. Can you summarize the core of your questions, Marty?
Yes, we probably wait for him to kind of type it out. I mean,
Sure.
we really wish that I mean his microphone was working. I mean, but unfortunately, it seems that his microphone is not indeed working.
Yeah. Maybe.
So I mean, I think he had a related question, or rather a one-liner question in our webinar chat too, saying like any suggestion for a 1D kind of multi-sensory signal data that I mean, like, and gives a bit more context too. So he says like his original interest in this area comes from bedside monitoring, which he kind of worked on in the late 80s, it seems. So so gradual data shift of patients in the ICU or CCU over the course of the day and over longer time scales as well. So I mean, I think this question was more along the directions of, any suggestions for such data that we can probably play around with, and how potential continual learning online methods would potentially work for that. I feel if I can get it clearly, I think, I mean, if I can understand them properly, I think this is what it is.
I'm not aware of any such data sets personally.
So,
Me either, but
yeah, I think our first talk in today's session, I think she actually had a couple of, I mean, with Savita, I mean, she used to work on a lot of, like, I mean, 1D data, time series data, and so on and so forth. I think Marty, I think, I mean, I mean, I think we already exchanged email addresses, right? I mean, so I think she would be the right person to kind of, help us with 1D data. I feel, I think she has a lot of IoT applications and healthcare applications and climate change applications and so on and so forth. So, I mean, I think she would be the right person to kind of help us with that, I feel.
mhm.
Great.
Is someone dismissed? I saw that the
I think
question came back.
I didn't dismiss it, but I answered it.
Okay.
Yeah. So he says, I mean, I actually not answered it. I asked the follow-up question on that, and Morty asked us, I'm just asking about selecting from an ensemble of alternatively trained classifier for the classifier that minimize the tendency to output outliers. I hope that clears up my question. So I was asking back whether it is related to any continual learning or not.
Yeah, I think one more thing that would be interesting to see in continual learning is how VLMs perform in continual learning tasks. I don't know if you saw this. It's a simple classification thing that they ask GPT, like, is it muffin or chihuahua? This very typical vision question. And
Right.
GPT output a grid of answers, classifying everything
Right.
correct.
Yeah,
So-
that was surprising.
So it is quite interesting. So I think seeing the intersection of language with vision in continual learning would also be interesting.
Yep.
True.
I also think that the models should go to the multimodal way. So the continual learners should also deal with this multimodal models as well. I mean, in the continual learning perspective, we don't care whether the model is multimodal or not, but maybe in the multimodal model, we probably have other issues to address. So maybe this is interesting, another direction to pursue that. Yeah, if there's any issues, particularly in the multimodal models, then yeah, this is another interesting research avenue for continual learning.
Right, I completely agree with you, Joe. I mean, I feel, I mean, to be honest, that was something that I used to be very much fascinated about. Is like when our learning is naturally multimodal. I mean,
Mhm.
we kind of see you folks, we hear you, and then we see the gestures, and then like, there's a voice modulation. So
Mhm.
so our central processing unit, which is a brain, actually gets all this information, and
Mhm.
even if we don't get complete information from one modality, I mean, the another modality might need supplement for, I mean, what is indeed actually not there in the other modality. And to be honest, in whatever methods that we kind of build, that is brightly missing. Right. I mean, I feel, I mean, if we graduate to some kind of a multimodal continual learning system that can consume multiple modalities and then make use of each of the modality in an appropriate fashion. So maybe if some information is rich in one modality, cater to it. If there are some other information that is kind of catering to another modality, maybe buy from it, and so on and so forth. So, but so far I haven't seen any system that actually tries to do that. So with the age of, let's say, all multimodal foundation models that are out there, so is it a right time to kind of go ahead and revisit and pitch that problem of simply multimodal continual learning?
I personally think so. I think, like, yeah, we have so many modalities out there. Particularly text might be very like comes naturally with images, because anything could be described by text. Like you could describe anything by text, and videos come naturally with audio, for example. So there are associated modalities that come almost for free, let's say, or in the case of videos, audio is for free, but in the case of images, captions might not necessarily be for free, but weak captioning is possible using those massive blip foundation models and so on. So I think we should leverage those capabilities and those modalities because they are there. Like, why not? It should definitely improve performance at least.
Sure. I think the tricky part over there would be to gauge the information, let's say, the amount of information that indeed comes in each of the modality, and then gauging it, and then, I mean, attending to that differentially, right? I mean, I think that is something that we just do. I mean, we just naturally do, but not sure how we can probably find that optimal combination of these modalities, that information extraction from the modality, and then combining them together to kind of make a informed decision from the multiple modalities. I mean,
there was recently a paper in accepted to NeurIPS, which is called multi-mod N, and they propose a very modular setting where you can they kind of address this problem. They say, what if suddenly you get a modality, or like you have certain modalities? We want to keep it in a very modular way, and they kind of try to address this problem exactly. I could share that.
okay. Yeah. What is that paper title?
I could share it in chat. Just let me grab it out.
Sure.
Yeah, this one.
Yeah, thanks for sharing.
Yeah, so people have been seeing this. I think people are interested in seeing how modalities could be integrated if effectively without fiddling around with other modalities. Like, you still want to have this capability of dropping a modality completely if you don't have it at test time or at train time, for example.
Interesting. Very interesting. Okay. I mean, I feel that would be, I mean, that's in line with most of the discussions that we had today on kind of building up that robust system that can go out in the world and then incrementally learn, and then from a stream of data and so on and so forth. I feel, I mean, this multi-sensor information or multi-sensory information coming in together in an online setup, I feel that would be very, very advantageous. Awesome. Yes. So, I mean, I feel we are getting to the top of the hour, and I feel, I mean, so the major things that we kind of had discussed so far was like metrics, benchmark, whether we feel that all these are good enough for 2023 and beyond, and so I mean, but I mean, so so any last minute wrap up thoughts from both of you? I mean, on where we are heading to, and then I mean, any advice for the folks who are actually here on who are interested in online continual learning, let's say maybe regarding the metric selection or managing some kind of constraints and so on and so forth. So yeah, any closing remarks from both of you?
I think particularly for online continual learning, I feel like their metrics should be improved and data sets should be improved. So currently data, like using simply online accuracy, turned out not to be the ideal metric. We proposed a near future accuracy metric, which is also which captures only label correlations. But what about if you have correlations in terms of pixel distribution? Like, there's some bias in the data set itself. I think this is an unaddressed problem in terms of metrics. So this, we just have a correction for label correlations, but there could be different kind of correlations across the pixel space. Data sets, I think current data sets they are kind of natural data sets, but they might not be enough. It seems they have a lot of label correlations, and we cannot simply clean them. We cannot say, oh, I will remove samples to remove correlations, because then you're basically fiddling around with what the stream would have looked like actually. I think interesting problems would be how can we do some online learning on language models as well? People have been really focused on continual learning on vision, but I think language seems to be very interesting. If you try to fine tune some of those large language models like Llama or something, they really collapse in terms of knowledge at a certain point if you don't train with those very small learning rates, and then emergence of knowledge is sacrificed. So I think as future directions, language models, foundation models, learning with changing architectures. Those are quite interesting problems, rather than like just saying, oh, well, we restrict memory to 5 samples. You can only store 5 samples and do it on Cypher and those toy examples. I think they are less interesting and less applicable in real life. Like no one would suffer to store 10 megabytes or something.
Yeah, I completely agree to Hassan that we have to switch our attention to the large foundation model for continual learning, also their behaviors on the data stream. And also we have to think about the total constraints of all of this budget. So, whether we are constraining on the right size of the the right size of the memory budget or right size of the computational budget. Because the online continual learning say, yeah, we only allow one iteration of a training, but each of the iteration will take different time for different methods. And these are constraining on, they are not actually constrained on the same kind of budget. So even though you're saying, yeah, we are looking at the samples once, but in the process they may use that information multiple times in the one epoch, which is not really fairly comparable. So we also think about this computational budget in a more serious way, and the memory budget in a more serious way. Here, the memory budget not only consider the episodic memory size. Even though we don't use any episodic memory, we have to store some of the previous logic when you're using this data priors and when you're doing this network expansions and things like that. So here we really have to think about this the total memory budget and total computation budget to compare the methods in a fair ground, and also make all the methods more realistic and more practically useful. Otherwise, some methods are working awesome, but they're taking forever to do the one epoch of training. Then, yeah, this is not actually useful. So, yeah, this is the thing that we have to think about. And for the metric, we have to think about this the accuracy-based forgetting, and we also think about how to measure the amount of knowledge that we have gained on the new information. These are not actually well analyzed in the previous literature. So we say, yeah, we probably prevent the forgetting, but by looking at the accuracy, it is actually forgetting. But when we don't know, I mean, by looking at the accuracy over averaged accuracy over all classes, then this is not really a good metric for that. And in our SDP paper, the continual learning paper, we actually suggest a new metric for the forgetting and the amount of information that you have gained by using the information gain, by using the differential entropy. So by doing so, we are actually breaking down or partitioning the average accuracy over all classes, but just looking at the accuracy per classes and see how much accuracy per each classes are moving across the task or across the sample injections. But they are still looking at the accuracy. So we may really think about the loss values or the amount of information for each of the parameters are learning, and maybe we may think about more foundational solution for the catastrophic forgetting, not only for the continual learning setup, but also the general learning setup of using neural network. Then we can actually solving the continual learning problems, I guess.
Right. I mean, I think these both. I mean, I think these are very, very insightful discussions that we're kind of having. So, I feel the bottom line is online continual learning is here to stay, and I think we are actually picking on the right problems and trying to solve the right things. And I think we are in the right directions. But of course, we need prodding here and there on maybe stepping up with the benchmark, stepping up and being much more open to, let's say, using foundation models, and so to say, and then limiting ourselves on a couple of axes that we kind of constraining, for instance, like the type of so on. I feel just be a bit more open and then embrace all the new happenings around us, and then make the real online continual learner. I feel this was a very, very thoughtful, insightful discussion that we had right now. So
Glad
I feel that's a wrap. We are I think we are on time. So I really want to thank both of you, and of course our audience too. And Marty, we really missed you. We really wanted to hear from you. So thank you for all your comments so far, Marty. Really appreciate your help also, and all the audience, so everyone. So yeah, I think with that we can probably wind up this session. And
Thank you very
big
much for
thanks
hosting that.
to
It was a very interesting discussion.
Yeah, thank you very much for having me.
Sure. Yeah. Thank you very much. Yes.
Thank you.